2.1, the four operations in algebra. Our learning intention to solve algebraic expressions using CAS. Our success criteria: I can solve algebraic expressions that involves 4 mathematical operations. I can use CAS efficiently and solve expressions. This chapter is very CAS heavy, but my aim is to go through the PowerPoints and show you that you don't have to use CAS if you don't have one or you don't know how to use one. Completely up to you, but do not think that just because you don't have a CAS in front of you, you can't complete this. So first of all, our 4 operations. We're talking about plus, minus, or addition, subtraction, multiplication, and division. Our 4 operations. The plus, minus, times, and divided by is stuff that we've seen since, I reckon, grade prep. So, definitions used in algebra. Algebra involves letters and symbols that most of the time freak a lot of people out, but I'm going to try and get that out of the way and show you that it's not that scary, that are used to represent unknown or generalized numbers. A pronumeral is a letter or symbol that takes the place of an unknown or generalized number. So, a lot of the time, a pronumeral that we would see is X, Y, A, B, C. Just a letter out of the alphabet most of the time. A variable is a letter or symbol used to represent a quantity that can have many different values in a particular situation. So, we can change our Y value based on how many X's we have. If, for example, our Y equals 2X, every time we have 1X, we have twice as many Y's. So Y is our variable. A term can be a number and one or more pronumerals multiplied together, or a number or pronumeral on its own. So when we were talking recursion, we saw what the terms were. They were a number. In this instance, term is used slightly differently. If I said 2a plus c plus 3, that 2a is a term. Then the plus c, so we have to incorporate that operation of addition. Plus c is a term, and one more colour, plus 3 is a term. So you do take into effect or into consideration the operation that is before the number or the letter, etc. So a coefficient is the number that appears before a variable in a term. So if we were talking 2a, the a here is your coefficient. A constant term is a term that contains no variables, so it's just a number by itself, like the number 3 up here. An algebraic expression is a collection of 2 or more terms. These terms can be added, subtracted, multiplied, or divided. An algebraic expression does not include an equal sign. Examples of algebraic expressions are 2m subtract 3n, 4a plus 7b, 6uv subtract 2w, add 4v, and negative 9ahw divided by klm. So we're going to move on to a worked example. I'm going to use a few different colours here just to show you what's where. In the algebraic expression, p minus 5qr plus 7, where p, q and r are variables, identify the number of terms, the coefficient of the term containing the variable p, and the constant term. Now we'll go back to blue. I'm going to write this out. P minus 5qr plus 7. So it didn't really give me too much room here. This p is one term. Now, if there's no positive or plus symbol at the beginning, you automatically assume that the first one is positive. If there was a negative there, it would be a negative term. But in this case, it is positive. Then our second term, we go from that first operation there till the end of the pronumerals, just before the next operation, is negative 5qr. Then my last one, I'll do it in blue. is plus 7. So, based on that, I can answer A, the number of terms. So I've broken this up into 3 terms. P, so P is one term. Negative 5QR is the second term. And my third term is just the number 7. Part B asks the coefficient of the term containing the variable P. Now, if we're remembering algebra, if there's no number there hiding before that P, you know that there's a number 1. So the coefficient of the term containing the variable P is the number 1. You don't have to write the number 1, we just assume that there's a number 1 there. And then our last one, the constant term. So the constant term is the one without any letters attached to it, and that's the number 7. So A, the number of terms, is 3. B, the coefficient of the term containing the variable P is 1, and the constant term is 7. Adding and subtracting algebraic expressions. Like terms are composed of the same pronumerals raised to the same power. The pronumerals may be in different order. Examples of like terms include the pairs 4a and 2a, 3xy and negative 6yx, and negative 2abc squared and 5c squared ab. Only like terms can be added or subtracted. Okay, think of your fruit bowl. Can you add apples and bananas and end up with the same fruit? No. You can only add apples and apples or bananas and bananas. But if you had an apple and a banana, you could add a second apple and banana because they are like terms or like fruit. Answers should generally give pronumerals in alphabetical order. There's no hard and fast rule to say you have to, but it's a little bit neater looking. For example, write negative 3a plus b rather than b minus 3a. Note, though you won't be marked as incorrect if pronumerals are not in alphabetical order. We don't hold it against you how you write it, so long as you give us the right answer. So, when it says, we'll go back and read through a couple of these lines. Like terms are composed of the same pronumerals raised to the same power. Now, in this case, 2m and 2m squared are not the same. Because there's no power on top of that m, it's raised to the power of 1. And something to the power of 1 is different to something of the power of 2. Let me go back to blue. 3xy is the same as 3yx. So if you have a look, my x and y are the same. They're just written in a different order. Now, when we get to CAS, the order of your pronumerals actually matters. Sort of. But remembering with your adding and subtracting, you can only add and subtract like terms. So, using a CAS, I'll run through the CAS quickly. If you are to type in, say in this example, 3my, and then you had a different number that said 4ym, it wouldn't recognise the my as being the same as ym. So instead you do 3 times m times y, and then you do 4 times y times m. This would then recognise all those pronumerals or the letters as being the same letters. Even though the coefficient or the number at the beginning are different, it doesn't make a difference. It's about those pronumerals. So that means that this m is the same as this m, and this y is the same as this y. We put a multiplication sign in between each of the coefficients and the pronumerals. So use your CAS to simplify 3xy minus 6yx minus 2abc squared minus 5c squared ab. Have I got room on the next? Nope, I'll pop it on this page in a second. I'm jumping ahead a little bit. Now my first one is simplify 3my, take 7m plus 2 plus 3m. Now I'm going to fill it in at the bottom of this CAS screen. The CAS has already done it for me, but I'm going to show you by hand. As I said, not everyone has to have a CAS calculator. So 3my minus 7m plus 2 plus 3m. The first thing I would do is put all the like terms together. So 3my minus 7m plus 3m plus 2. So I've got my m's in the middle there together. 3my, are there any other my's or ym's? No, so we keep that the same. 3my. Minus 7m plus 3m. There's no other m's either side, so I know that that's minus 4m, and I've got a constant of 2. And that's how I would simplify my, my expression. On to the second one, 3xy minus 6yx minus 2abc squared minus 5c squared ab. Now, having a look at this, x and y is the same as y and x, and abc squared is the same as c squared ab. Just the pronumerals are in a different order. So, if I was to write this out by hand, I would do 3xy minus 6yx. 3 takes 6 is minus 3, and xy. Yx, xy doesn't make a difference. Then I would subtract. Minus 2 take 5 is minus 7. And I keep my a, b, c squared. That doesn't change because I'm keeping this. I've got like terms. The like terms don't disappear unless you get to 0. If I was to put this into the CAS, however, I would put in 3 times x times y minus 6 times y times x, subtract 2 times a times b times c squared. Now, when you're pressing the squared button, there's a little x to the power of 2. That will automatically give you a squared. Easiest way to use the to the power of 2 indice. Otherwise, if it's to the power of 3, you use a little hat to the left of it and then add your power from that. So keep going. We'll go minus 5 times c squared times a times b. And then press enter. And CAS will give you negative 3xy minus 7abc squared. On to slide number 6. Multiplying and dividing algebraic expressions. When two numbers of the same sign are multiplied or divided, the result is positive. So, if you had minus 2 times minus 3, I've got negative and a negative, so I'm going to end up with a positive. That's what it tells me here. So I'm going to end up with positive 6 because I know 2 times 3 is 6. Negative times a negative is a positive. If I have two positives, I'm going to end up with a positive. And the second dot point, when two numbers of different signs are multiplied or divided, the result is negative. So if I had, I'm going to pop it across the top here, if I had plus 4 times negative 2, I would end up with negative 8 because I've got a positive and a negative which are different signs, and I'd end up with a negative. When multiplying and dividing algebraic expressions, the terms do not have to be alike. When multiplying algebraic expressions, simplify by multiplying the numbers, then the pronumerals respectively. 3a times 4b. You would start by multiplying the numbers. So 3 times 4 gives you 12. A times b gives you ab. As the note says, they don't have to be the same. When dividing algebraic expressions, write the expression as a fraction and simplify by cancelling the numbers, and then the pronumerals. Using the highest common factor, HCF, the answer is usually written as a fraction. It doesn't have to be, but it can be. So I have one multiplication and two division examples. So 5PQ times negative 3PR. By hand, we can start with 5 times negative 3. So back to my blue. 5 times negative 3. 5 times 3 is 15. A positive times a negative gives me a negative. Then I do PQ, PQ, PR. Now I've got two P's in there. So they're now going to be squared. So negative 15 P squared QR. And that's my answer. We can put this into the CAS, but again, we have to put a multiplication sign between everything. So you would put in 5 times P times Q times negative. Now there's a negative button and there's a subtraction button. Use the negative button, which is the little dash in the brackets, multiplied by 3 by P by R, and you would still end up with exactly the same solution. Dividing is a little bit trickier, but not too hard. We can either do it or write it as the first term divided by the second term, or we can write it in fraction form. I will tell you that if you're doing it by hand, to write it in fraction form, it is a lot easier than to write it in division form. So I'm going to pop this into division form. 28 xy over 21, no, not x, we want y, yz. Now, thinking about the factors of 28. The factors of 28 I've got are 1, 2, 4, 7, 14 and 28. So what numbers go into 28? Then my factors of 21 are 1, 3, 7 and 21. Based on this, I can see the highest common factor is 7. So that's the largest number that goes into both 28 and 21. So if I was to divide that by 7, 28 by 7, I would end up with the number 4. And if I was to divide 21 by 7, I would end up with 3. Now I'm keeping the red pen on so I can show you what I'm changing. Now, we've done the numbers, we need to move on to the letters or the pronumerals. Having a look, I've got an X in the top line. Do I have an X on the bottom line? No. If I don't have an X on the bottom line, I keep X on the top. Then looking at my next pronumeral, I've got a Y on the top. Do I have a Y on the bottom? Yes. I have one Y on top, one Y on bottom. They disappear. And then my last pronumeral is the Z. I have one on the bottom, nothing on the top, so this one stays on the bottom. My solution is 4x over 3z. Now, if you glance down at the bottom of the PowerPoint there, you'll see that into the CAS, it is exactly the same. It is 4x divided by 3z. Now, when entering into the CAS, you can do it one of two ways. You can do it as a fraction and put the top fraction, the top term, with the multiplication sign in between each of your coefficients and pronumerals, and then divide it by the second term and put the second term on the bottom of the fraction. Or, if you choose to use the divided by sign, you need to use brackets. Because if you don't use brackets, it will not recognise that entire term. Following the BODMAS rule, it will do the division of the number, then it would multiply by the pronumerals rather than continuing to divide by them. So you could do 28 times x times y divided by, open bracket, 21 times y times z, close bracket. So what that means is that instead of dividing by just the 21, it's dividing by that whole term because that's encased in the brackets. Now remember, our BODMAS or our PEMDAS, whatever your order of operations rule is, it will do your brackets first. So it will calculate your brackets and say 21 times y times z. That whole thing is going to then be divided by the 28 term. All right, next slide. I have another fraction. So I'm going to do this by hand as well and then show you what to put into the CAS. So we have negative out the front and then we have 36m squared n and 9mnp. First of all, my highest common factor. My factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. And then my factors of 9 are 1, 3 and 9. From this, I know that my highest common factor, so the biggest number that goes into both of them, is the number 3. So dividing my I stand corrected. My biggest number is 9. Forgot about that one. So divide that by 9. So 36 divided by 9 gives me 4. And on the bottom, 9 divided by 9 gives me 1. Now, I'm going to break this down and show you no, scratch that. I'm going to delete that and go back to that. Jumping back and forth, I apologise. So I'm going to actually separate it out. So negative 36 m squared, which is m n over 9mnp. Just so that people who aren't quite comfortable to do to play around with indices can see where I've cancelled out. So cancel that out, divide that by 9, I end up with 4. Divide that out, I end up with 1. So my new fraction will have 4 on the top and 1 on the bottom. Then I'm going to start with my m's. I've got m and m on the top, and I've got a single m on the bottom. So 2 m's at the top, 1 on the bottom. Let's get rid of 1. Let's get rid of 1. I still end up with 1 m. So we'll pop that on the top. Then I've got n on the top, n on the bottom. So get rid of 1n, get rid of 1n, and I don't end up with any n's. And I have one lonely p left on the bottom. So I have negative 4m on 1p. Do we need to write the 1 on the bottom? No. So negative 4m on p is my solution. Now, I could have used the CAS for that, but I didn't need to. Doing it step by step will give you the knowledge and the understanding of what to do. At the end of the day, if your CAS dies, you're going to have to do it by hand anyway.